Algebra 2, we're in a new chapter, Chapter 5, and we're doing Lesson 5.2, Characteristics of Quadratic Functions, Characteristics of Parabolas. So as we can see our learning target, I can use technology to find the real zeros or the real x-intercepts of a quadratic function. We're going to use a website to help us out. F of x, of course, is really just another name for y. I hope you know that from your days in Algebra 1. Just reviewing that. F of x is function notation. But we're going to try to find the real x-intercepts of this parabola. We need to graph. And what you're going to do is go to Desmos.com. Desmos.com is going to allow you to quickly and easily get a graph made. So I'm going to just type in a y equals -4, and to get an x, I'll hit an x, and then I'm going to hit the caret button right above the 6 there, Shift 6. And you can even hit the up arrow, I believe, and do the same. If you just hit the right arrow after that, and then hit a plus 6x, and then a plus 2, you can see you're going to get very nicely your graph taken care of. So we're going to use technology to find all the real zeros here. So as we're looking at this, we can just click and see that we get 1.78 roughly going to the nearest hundredth right here. Click on this other x-intercept and you'll get -0.28. So you can see that's really what we're going to be doing, just letting this curve get taken care of real quickly. So back to our sheet right here, and it says find all the real zeros. Well, those are the real x-intercepts. You could go in either order, but we're going to have to go to the nearest hundredth in general. 2 decimal place accuracy, we're going to have to be able to round. Let's do example 2. It's going to be pretty much the same concept, except not only will we find the zeros, the x-intercepts, we're also going to find the vertex. So I'm going to come back here, and this time, just real quickly, start off with a y, and we'll get y equals, but this time we're going to type in 3.38x, and then you can even hit the up arrow. Well, my up arrow isn't working on this. Maybe on your Chromebook it will. I'll use the caret, Shift 6, and 3.38x squared. You have to move over, hit the right arrow, go 5.2x plus a 2. And, oops, looks like something got messed up here. I think the plus 5.2x got a little bit messed up. The nice thing is you can see exactly how you're typing it out. If you're matching, this really is, in fact, what we have for our situation. Look at this x-intercept. As you come down here and as you click, you're going to see that your x-intercept is, in fact, your vertex. That can happen. It can happen. Now, you'll have -0.77 when you round to 2 decimal places. -0.77. So this is one of those rare instances where, your x-intercept also happens to be your lowest point. So I'm going to bring this back and say, what's our vertex? Well, we just saw it was -0.770. And we can bring that back real quickly. But we also can say that our x-intercept, if we've got to click that in, that's just going to be -0.77. The x-intercept, or the zeros, are numbers. They're numbers where you cross the x-axis. The vertex, though, you're always going to have to write that as an ordered pair, as a point. Okay, so we're going to come to number 3, and really that should be -2x squared plus 12x minus 16. So let's come back over here and just make a quick change. You again could hit y equals, and we'll type negative 2x, and I'm going to get that power in there, negative 2x squared. Move it over, say plus 12x, then a minus 16. And they're asking us a number of different questions here. First off, and you can see we've got some gray dots. First off, they're saying, does this function have a minimum or a maximum value? Well, as you look right here, you can see you've got the high point. This is a maximum point, the top of the mountain, so to speak. So we're going to be able to say that that's a maximum value. And the word value is always going to be associated with a y value. So you've got something like that. What is this maximum value? Well, again, it's the y coordinate here. It's the point 3, 2. You can see I'm clicking on that. And you can see where we're going. What is that maximum value? The maximum value is 2. I'm going to put a star over here. It's always the y value. The maximum value is right here. Where does that occur? Where means that we've got our x coordinate. Whenever they say, where does this occur? It's the x value of your vertex. That's going to be at x equals 3. Okay? So it's pretty straightforward. You're going to be able to just type your parabola out. You're going to either find a high point or a low point and then move on from there. Take a look at example 4. Guys, example 4, it can get a little intimidating. Big numbers. A vehicle factory manufactures cars. The unit cost, that is the cost in dollars to make one car or each car, depends on the cars made. Here is this real big equation. So they want to know what the minimum unit cost is, and that's going to be your y value on a vertex here. So let's go ahead and get this thing typed out. It's going to be ugly. It's y equals 0.5 x squared. So I'm going to get my power up here. I'm going to move over, and then we'll say minus 270x, and then plus this 49,764. And what will intimidate kids, I'm sure, is, not only do you have some big numbers, but you look right here and you're going to say, hey, I'm not really seeing what's going on with this graph. I'm not seeing anything. Well, you can definitely zoom out, and I recommend that you do. You can just keep going until you begin to see a parabola. And hopefully you're going to be able to see it relatively soon. You can see right here, all of a sudden you begin to see it. It was way up high, and now maybe you could begin to magnify and come in. All you got to do is click on that vertex. The parabola might be way up high, but what they're showing you is it's the point 270 and then 13,314. So we've got 270, 13,314. Let me go back real fast to our notes right over here and say, look, at the end of the day, you've got a parabola that's opening up, and we just saw it was 270, 13,314. Remember, it's your y value, your y coordinate, that is a maximum or a minimum value. So that cost for the car, the minimum cost per car, is $13,314. It happens to occur if you're producing 270 cars if X cars are made. But they just want you to go straight to that. Okay, well, let's keep going over here. And, the next problem, my goodness, you don't even need Desmos. You don't need anything to help you out in that regard. It says, find the domain. The domain and the range are what we're going to look for. The domain is going to be all possible X values. And guys, here's something very, very, very important. Every single problem that you do with a parabola, the domain will be all reals. Your X values will always be allowed. You can use any X value. However, when you look at the range, you're talking about Y values. Look at this vertex. You can see that this vertex is at -1, -2, comma, and then we'd go 1, 2, 3, 4 steps down. You can see that's your low point. And guys, your range is what kind of Y values you can have. I hope you can see that the smallest Y value you could ever have is -4. You could get larger. You can go all the way up to like Y values of 2 or whatever you'd like. You can't get smaller than -4 though. So you're going to say Y is greater than or equal to -4. All right. By the way, if you would have had an upside down parabola, just to talk about that for a minute, let's say that this was the point 3, 6. If that was your problem, you could see that your Y values can only get as big as 6. This range would be Y less than or equal to 6. Alex sometimes will give you an upside down parabola, and you always look at the Y value of your vertex to help you out. All right. Here's a last problem. I can choose a quadratic model. Imagine that these blue dots that you're seeing are data points. They're data points that show an ocean trench's depth at a distance X from a marked buoy. So the depth is in Y, and X is your distance from the marked buoy. So as you just look at figure 1, figure 2, and figure 3, you got to ask yourself which of these 3 curves fits the data the best. Hopefully, you've done this in science. You plot some points and you try to get a line or a curve as close to your data points as possible. Look at figure 1. This curve is very far away from all the data points. Figure number 2, it's kind of going in the middle, but it's not really tracing out that pattern. Whereas look at number 3. It's clearly going to be figure 3 best fits the data. That curve gets closest to all the dots. And that's what we're going to have for an equation. That equation they give to you is going to be about as close as you could get. So part B, they're saying use the equation to predict the depth of the trench 60 feet from the buoy. That is, you want X to equal 60. Well, tell you what, we can take our calculator out and we can say, look, here's your equation, and I'm just going to type in negative 0.37, or you could go 0.37. Now your X value is 60, so I'm going to put parentheses here and just square it, plus 55.6 times X, but what's our X? Well, it's 60. And then finally we'll go minus 305.1. And once you hit enter, you'd get 1,698.9. 1698.9. And notice they're saying not a rounded answer. So even though that's not a whole number, it's still a valid answer. So that's what we're going to be doing for homework 5.2. Take a look at that, and hopefully using Desmos, you'll have success.